Okay, we have a 100 volt. So we're going to start here with a review question. It's a simple parallel circuit question. We have a 100 volt battery, a 10 ohm resistor, and a 40 ohm resistor in each of the two legs, and three relatively simple questions. What is the current through each leg? What is the total current? What is the total resistance? Both methods. So, what is the current in each leg? To do that, we're going to say, hold on a second, I've got to change the color of the pen here. Okay, so we're going to start with V equals IR for that leg. So we're going to say 100 volts, because if that's 100, each leg gets 100. I, 10 ohms. So that leg is going to get 10 amps. Okay, we're going to do the same thing over here. We got V equals IR. So this V is going to be equal to, oh, scratch that. Okay, ignore this. We got 100 volts. I times 40. Do the math here. Comes out to be 2.5 amps. Okay, so B says what's the total current? Well, if we got 10 going through this leg, 2.5 going through this leg, it's 12.5. Oh, it's 12.5 amps. Now, what is the total resistance? And it says both methods. So the first, in this case, easier method, because of how much work we did, is going to be V total equals I total, R total. Okay, so we know V total is 100 volts. We just found I total to be 12.5 amps, R total. So we divide both sides by 12.5. R total is 8 ohms. Okay, now the other method is using the formula, which is 1 over R total is equal to 1 over R1 plus 1 over R2. So we got 1 over R total is equal to 1 over 10 plus 1 over 40, which is 4 over 40 plus 1 over 40 with the common denominator. So 1 over R total equal to 5 over 40. R total is equal to 40 over 5, which turns out to be 8 ohms also. Okay, so now here's what we're going to do today. We're going to work on a slightly different scenario. So what we have here is we have what's called a combined circuit. The reason this is called a combined circuit is, well, it's exactly that. It's a combination of both a series circuit, which is this combined with this. So that is a series circuit. That is a series circuit. And it's also a parallel circuit because we have the two separate legs here. So we're going to let this be 90 volts. Now, in a typical parallel circuit that doesn't have this here, each of these legs would get 90. But we have to remember back to what we talked about with series circuits. And with a series circuit, the current comes out of the battery with 90 volts. Then it drops some of its voltage here. And then if we're looking at, let's say, just this round, this series, then we drop some of it here and some of it here. But the current that comes out in this case and goes the other way, so this current is going to drop some here and some here. So it's, instead of being two simple circuits as the two loops, it's two series circuits. So what do both of those loops of current have in common? Well, they both have to drop voltage here. Okay, so what we need to do ultimately, we need to find out how much voltage gets dropped across just this guy. If we can find out how much voltage gets dropped across this guy, let's say for argument's sake it's 30. It's not. We'll talk about it in a minute. But let's say it's 30. 90 here. Drops 30. There's 60 left. So then each leg would be supplied with the additional 60 that was left. You kind of follow. So How are we going to go about finding that? Well, easiest way would be to think, if we're going to call this resistor 1, to say V1 equals I1 R1. Okay, so the problem with this right now is we don't know V1, that's the question. We don't know I1, and we do know R1. But what we can go on to say is, since we don't know that information, we do know some other information. For instance, we know that because this current hasn't broken up yet, I1 is the same as I total. So maybe we'll look into doing this a different way. So what if we said V total equals I total R total? Well, now we know V total, it's the 90. We're looking for I total and we don't know R total. So it kind of seems we're in the same spot. However, here's where this gets a little bit easier. We can, because we know every single resistor here, we can find R total. It's just going to be a little bit trickier. So here's what we're going to do. We're going to look at this piece first. This piece, this whole piece, is two resistors hooked up in parallel. So we can find the resistance of just that piece. Now, you remember way back when we talked about R total, I said that they will occasionally call this R equivalent. Well, here's why. If I do this math, so we got 1 over R total equals 1 over 10 plus 1 over 10, which is 2 over 10. So R total is equal to 5. That's the same as saying R equivalent, which means if I were to take out these two pieces, this big chunk, I could put in one resistor of 5 ohms, which would be equivalent to this setup. So what does that look like? That means I would have a circuit now that had this 90 volts, this 10 ohm guy, and now I've taken out that other piece and put in one resistor that's equivalent to it. So took out this piece, put in one resistor that's equivalent to it. Now this is easy because I have a series circuit. So now if I want to find R total, it's going to be 10 ohms plus 5 ohms, so 15 ohms. So the equivalent resistance of this circuit, and more importantly, this circuit, is 15 ohms. Okay, so we can go get rid of some of this stuff. Now we're going to say V total, I total, R total. V total is the 90 volts. I total is what we're looking for. And R total we just found to be 15 ohms, which means I total would be 6 amps. So why is that important? Because again, remember that we were looking for the current going through this guy. And why were we looking through the current going through this guy? Because we want to ultimately find out the voltage dropped on this guy. So now I could say V1, I1, R1. So V1 equals 6 amps times 10 ohms, 60 volts. So that means that 90 came out. I dropped 60 here. Remember, this is the drop of 60. So that means coming out the other side, I only have 30 left, which means each leg gets 30 volts. From there, I can answer any number of questions. I can find out, for instance, what the I in each of these legs is by just doing V1 equals I1 R1 and V2 equals I2 R2. So we get 30 equals I1 times 10. So the I in here ends up being 3 amps, which means the I in here would have to be 3 amps also, because 6 came into this juncture, 3 and 3 would have to go out that way. You could also have argued that since they're both the same resistance, they're going to take the 6 amps coming out of the battery total and split it evenly. That'll come in handy later when we do some of the other questions. Okay, so now let's look at this guy. This guy's a little bit more complicated. Not terrible, but just a little bit more complicated. So you can see that they're kind of starting to give you the same hint that I'm going to give you now, which is if you can find the total values, it's usually a home run in terms of finding the other things. So let's start by trying to find R total, because R total is almost always the number one thing you want to know in a complex circuit or in a combined circuit. So R total, what we're going to do is we're going to look at the circuit and we're going to say, well, this piece looks like it doesn't fit in. But it also, if you look at it, this piece, this parallel little chunk, is in series with these two. So if I can find out the equivalent resistance of this thing by saying 1 over R total equals 1 over 8 plus 1 over 8. This is 2 over 8. 1 over R total. R total is 8 over 2 or 4. So what that means is instead of looking at this as these two separate things, I could put 1, that's 4 ohms. Now, put another way, I'm going to add a page here. The way I was taught to do this when I was in school is kind of redraw the picture as we go. So we have a battery. Not even going to put any real math in here. Resistor here. I have these two guys here. And I have a resistor here. Now, as I simplify this, so I took this piece out and I put in an equivalent resistor. So then, what do I have? Well, I have this guy, and this guy. Now this, so if we go back to our numbers, this was 6, this was 5, and this was my 8 and 8. We just found this combination to give me 4, right? So if that combination gives me 4, now I just have a nice, easy series circuit. So our total is going to be 6 plus 4 plus 5, which is 15. So I come over here, and this is 15 ohms. Okay? Now, once I have that, I can find I total pretty easily, right? So I can say V total equals I total, R total. So V total is 60 volts. I total is what we're looking for, and R total is 15 ohms. So I total is equal to 4 amps. Okay, so I can put 4 amps up here. Now, knowing what we know about circuits now, I can also put 4 amps in 2 other locations because my current comes out here. It goes through this guy before it splits. So before it gets to the parallel circuit element, it goes through here. So this is going to be 4 amps. Then it splits up. It goes its 2 different ways. It gets back together. And then it goes back into the battery here. So this current here had also better be 4 amps. So we're going to say current through R4 is 4 amps. And the current through 1 is 4 amps. So now it's a matter of these 2 currents. Well, these 2 currents, we're going to make a concept argument here. These are both the same resistance. So if these are both the same resistance, then whatever current comes in is going to get split evenly. We talked about this before. This is why I said, remember what I said before, because it came up now. So if we get to 4 amps, then each of these gets 2 amps. Because 2 went one way and 2 went the other. The 2 get back together, and that's why this guy is also 4. Okay. Now, we'll come back to another way we could have done that. So let's now do V1, V2, V3, and V4. Okay, so we'll do 1 and 4 first because they're nice and easy. Okay, So V1, I1, R1. So we have 4 amps, 6 ohms. Nope, that's a lie. Sorry. 5 ohms, 20 volts, 20 volts, 20 volts. Okay, now V4, we're going to say I4, R4. So this is also 4 amps, and this is 6 ohms. So that comes out to be 24 volts. 24 volts, 24 volts. Now, if we're looking at this as kind of a pseudo series circuit, we have 60 total volts. 20 and 24 are already spoken for. So we have 20 and 24. So we have a total of 44 volts already used. So what's left to be used in these legs? Well, it's going to be 60 less 44, which is going to be 16. Now, because these two legs are in parallel with each other, that means that each leg will get 16. Now, you could go through and you could do the math here. You could say 2 amps times 8 ohms. And if nothing else, you see that I didn't lie to you. And then this would also be 2 amps. And this would also be 8 ohms. And this would also be 16 volts. Now, one last thing to look at here. If we think of each quote-unquote loop of a parallel circuit as its own individual series circuit, let's use a different color even. If I look at the current that goes here, it goes this leg and just that route. Well, you have to get rid of 60. We get rid of 24 here. We get rid of 20 here. So we'd have to drop the 16 here. Or, let's go with a different color. Use bright green. I like bright green. Comes out here, still drops 24 here, goes this way and up. So that loop of current, the green loop of current, is still dropping 24 here and still dropping 20 there. So it's still dropping 44 total, which means it would still have to drop 16 here. Should hopefully at this point start becoming a little bit more comfortable with this. So we're going to do one last example. Okay, so we have this guy. I've asked for R total. I've asked for the current through each resistor, and we'll end up talking about the voltage also. Okay, so let's talk about R total first. So we're going to use that same method I talked about before, where we're going to take each element and we're going to break it down into simpler and simpler things. So we're going to start with these. 1 over R, 1 over 8, plus 1 over 8. So 1 over R equals 2 over 8. R equals 4. And just like before, I'm going to start by saying, well, geez. We started with this circuit. Okay, crudely drawn picture. And we just took this piece out. Okay, so now we have this. This, and this, because we're putting in what this is equivalent to. So this guy has now become 4, which is what we just calculated at. The rest of these, so this was 16, 8, 8, 10, 10. So these are all the same still. Now, what we notice, hopefully what we notice, is that now this leg and this leg are hooked up in series. So what we could do is we could take this piece and find out that our total for that leg is 20. And we could take this piece and say our total for that leg, since that's in series, is also 20. and we can redraw the picture like this. One 20 ohm resistor in that leg, one 20 ohm resistor in that leg. And now we got what we need. One simple circuit. So now if we want the equivalent resistance here, we're going to say 1 over R total is equal to 1 over 20 plus 1 over 20. So 1 over R total is equal to 2 over 20. R total is equal to 20 over 2, which is equal to 10. So I understand it's a lot of work. I do. Trust me. But completely doable. You just have to take your time and you have to do a little thinking. That's all. Okay. So, current through each resistor. Well, what we're going to do for this one is, since there's no total current, there's no resistor that's taking the total current, there's just two different legs, right? What we're going to do is we're going to look at each leg individually. So let's look at this leg first, right? We can even go back to our picture from before. That leg has a total resistance of 20. So if that leg is a total resistance of 20, and I want to say V in just that leg, let's call it leg 1. V in leg 1 is equal to I through leg 1, R of leg 1. Well, V through leg 1, since there's no other resistors here or here anywhere taking voltage away, this entire leg gets to 60 volts. So we got 60 volts. Now, I1 is what we're looking for, and the total resistance of that entire leg is 20 ohms. So I1, so the current in leg 1 is going to be 3 amps. Okay? So the current through, let's, I guess, label these. The current through, let's call them 1 and 2, is 3 amps. Okay, now, the other leg. Now, we're going to take advantage of, hopefully at this point, we know a little bit about circuits, a little bit more than we started. Okay, this leg also has the same resistance of 20 ohms. So if we went through and did the whole math for this leg, leg 2 would have a current of 3 amps as well. So that means that if I'm going to label, let's say, this guy 3, the current through 3 is going to be 3 amps. But not so fast with these, because we have a current come here, right? And then it splits this way. So 3 amps goes this way. And 3 amps goes either this way or this way to get back together to be 3 amps there. Okay, so that means that I4 and I5, if we let's say call this guy 4 and this guy 5, we can cheat a little bit and we could say that they're both the same resistance, as often they are. So they're going to split that 3 amps 1.5 and 1.5. All right. Not terrible. Now, if I asked you another current, and let's say, what's I total? Well, we just found out that 3 amps goes this leg, and ultimately 3 amps goes this leg. So I total would be 6 amps. Okay. So, let's not do that. Wait. Okay. Now I just lastly want to finish off with talking about the voltage dropped across each one of these, because we are used to this entire leg having just one resistor on it. So we would say that that resistor dropped 60 volts. but it's not just one resistor here. It's two different resistors. So if I want to find out the voltage drop across each one, so 1 and 2, I would have to say V1 equals I1 R1. V1. Now we just found out that the current in that entire leg was 3 amps, right? And R1 is just 10 ohms. So V1 is 30 volts. Which kind of makes sense, because if they're both the same resistance, we expect they're going to drop the same amount of voltage, and since there's only 60 to drop, each one would drop 30. So we know that this guy is going to drop 30. You can go through the math and prove to yourself that that guy's also going to drop 30. Okay, now, the other leg gets a little bit trickier, but it's not all that difficult. Let's look at the 16 ohm first, because this was our I3. Okay, so I'm going to say V3 equals I3 R3. Looking for V3. This is 3 amps. This is 16 ohms. 3 times 16 is 48 volts. Now, if there's a total of 60 and 48 got dropped by this guy, that means that each of these guys, no matter which way the current went, whether it went this way or this way, has to drop the additional 12. So we would say that V4 and V5 would both be 12 volts. Okay, so I understand that this is a little bit tricky. So, a couple things. One, I understand if any of you are paying attention to when this is getting posted, that it is 10:20 at night. So, between technical difficulties and all other such things, it took me till 10:20 at night to post this. So, why am I pointing this out? This is going to be the only assignment I post for you for the week, which gives you, I guess tonight, but you're probably not going to do it tonight, all day Wednesday and all day Thursday to work on it, curse, scream, get yourself together, contact me. I have no problem setting up either individual or small group Zoom calls, so contact me if you're having a hard time with this. We will have the Zoom call again on Friday, so feel free to ask me questions before that, but we can also spend as much time as we need talking about the assignment on Friday. And on Friday, I'm probably going to give you guys just one additional question on that. Now, the good news is this means we're done with electricity, which we've talked about already. We talked about on the Zoom call on Monday. The bad news, I guess you would think, is that means that we're going to have a test next week. So more good news is that means that all of next week is going to be review. So this is the last new stuff we're learning for arguably a week and a half until the test. And then we're going to do magnetism, and then we're going to do modern physics. And then, really big hooray, we're done with the curriculum. All right? So, let's keep it together. Let's stay positive. Let's not panic. Let's work on this assignment, do as best we can, and we will talk during the week, and we will definitely talk on Friday. All right? See you guys later.